Hello everybody, welcome to the Introduction to SIG Cluster Lifecycle. My name is Justin Santa Barbara. I am one of the SIG Cluster Lifecycle co-leads. I'm also a software engineer at Google. My GitHub handle is JustinSB. Lubomir and myself are going to be giving this presentation together, but we are representing the work of a great many people within the SIG.
Hello, my name is Lubomir Ivanov. I'm a SIG Cluster Lifecycle co-lead, software engineer at VMware's open source program office, and my GitHub handle is neolit123.
Okay, so what are we going to talk about today? We're going to talk about SIGs and what SIG Cluster Lifecycle is trying to achieve. We're going to talk about how we're trying to achieve that through multiple subprojects. We have time to highlight only a few of those subprojects, so we're going to talk quickly about Kubeadm, Cluster API, and component config. And finally, we're going to tell you how you can get involved and ask you to start your involvement today by filling out a survey that will help us figure out what we should prioritize in SIG Cluster Lifecycle.
What is SIG Cluster Lifecycle? In Kubernetes, we have special interest groups, also known as SIGs, and SIG Cluster Lifecycle is one of those. All the SIGs also have charter documents, and a charter document is something that defines what are the goals and non-goals of a particular group. SIG Cluster Lifecycle's objective is to simplify the creation, configuration, upgrade, downgrade, and teardown of Kubernetes clusters and their components. As a special interest group, we also have a vision to develop the tooling necessary to build a highly automated meta-cloud. A meta-cloud here means imagine something that is a Kubernetes cluster that can be deployed on any cloud provider. We want to avoid the pitfalls of the past because we had some unsuccessful experiments in the past. Everything should be declarative, API-driven, KAID-like deployment type of style, and managing these clusters should be as easy as managing the Kubernetes objects like pods. And that is a familiar pattern to everyone. We want to make the 80% use case simple and the 20% use case possible. Always consider a simple configuration available to everyone, but there has to be this advanced configuration that is still possible to the rest of the users. We also want to commoditize or standardize KAID's cluster deployments. So if somebody is looking at your cluster, eventually they're going to know that, okay, this is following a standardized way, a standardized pattern for cluster deployment. So on this slide, we have a diagram of the current stack of tools that we are working on. At the bottom, we have etcd-adm. etcd-adm is potentially a manager of etcd clusters, a CLI, and a library that is work in progress, potentially consumable by high-level tools. On top, we have Kubeadm. Kubeadm is a cluster bootstrapper, as a lot of people should know already. And Cluster Add-ons is a project where we are working on standardizing the way add-ons are deployed in a cluster and they're managed as a life cycle, like how do you upgrade them, how do you downgrade them. Cluster API, a lot of people should be familiar with Cluster API as well. This is a project where you can create clusters using a declarative model. It's very similar to the Kubernetes declarative patterns. So if you combine these tools, you can potentially produce artifacts that you can then feed to an image builder, and the image builder can create like a virtual machine image for you, and the virtual machine image can then be fed to the cluster provisioner, which is a layer on top. The cluster provisioner can create you a cluster that uses this virtual machine image. And finally, on the left, we have component config. Component config's idea is that we can configure all these components on the right side with a declarative API that is very similar to the Kubernetes API, and in fact it uses the same machinery. As a group, we are also trying to follow a particular philosophy, and that is arguably the Unix philosophy. We want to make each program do one thing and do it very well. The boundaries between the separate projects should be clear, and there should not be, ideally, that much overlap. every computing infrastructure project that initially meets one need, well, will eventually expand in scope to only meet several needs poorly. This is something that we have to avoid. We also expect the output of every program to become the input of another program. And combining all the tools that we have, we want to create this Voltron-like software. On this slide, you can see a Pseudo Voltron example. It's a immutable node update type of scenario. So on the left side, we have a CI that triggers a rebuild of artifacts, notifies an operator to update cluster manifests that are potentially consumed by the cluster API. The cluster API can then perform a rolling update, then a bootstrap provider, which in this case is Kubeadm, to trigger the new nodes to join the cluster. In this section, we would like to highlight some projects that we are currently working on. The first project we would like to highlight is Kubeadm. Our of you should be familiar with Kubeadm at this point. Kubeadm is a cluster bootstrapper. It has a simple task. It should create a best practice Kubernetes cluster for each Kubernetes version. It should have a simple user experience and the cluster should be reasonably secure. Kubeadm has a limited scope. It's intended as a building block, only deals with the local file system and the Kubernetes API. It does not deploy a CNI network for you. This is out of scope and you have to manage this yourself. You can pick a CNI solution and apply it over the Kubeadm created cluster as an add-on. It has a composable architecture and everything is divided into phases, mostly everything. It allows for high-level tools to break down the phase process and pick the elements that they want. And such high-level tools are, for example, Chef and Puppet. On this diagram, you can see example usage of Kubeadm. So the first layer is the infrastructure provider that can give you machines, such as a control plane machine designated for that role, and also regular nodes. The second layer is where the bootstrapping happens and also the Kubernetes API creation. And finally, the third layer is where you can apply add-ons. That is the infrastructure orchestration. Also, cluster API is there. So based on a cluster API specification, you can trigger a certain implementation of the cluster API to reprovision infrastructure for you. The Kubeadm project has a roadmap. We want to simplify day 2 operations. To do that, we want to create a Kubeadm operator. The Kubeadm operator's idea is to allow the users to manage some features that are currently missing in Kubeadm. For instance, we mentioned earlier, a tool should be designated to do one thing, and it's out of scope for Kubeadm to manage all the nodes. Because Kubeadm is run on a particular node, it does not know about the other nodes in the cluster on the infrastructure level. So you should be able to reconfigure these nodes using the Kubeadm operator and potentially by utilizing a declarative pattern. We want to support different workflows like changing the cluster behavior overall or certificate rotation. We want to make Kubeadm friendly for high-level tools. We want to do that by enabling machine-readable output. Currently, machine-readable output is only possible for some of the commands. We want to enable it for all the commands. And we want to make the phases for Kubeadm init join retriable and, where possible, idempotent. We also want to increase the flexibility around add-ons and etcd. By leveraging some of the ideas of cluster add-ons, we want to transition our core DNS and kubeproxy deployments, which are currently the core add-ons in Kubeadm, to operators. And we have to also lower the barrier between what is considered local etcd and external etcd. We want to simplify component config management. We are going to talk about this later in the slides. And also, very importantly, move Kubeadm out of tree. Out of tree means the Kubernetes repository. And around that, we have to define a new release process and build automation. And this will allow easier vendoring for those that wish to consume Kubeadm as a library. If you want to learn more about Kubeadm, we have a Kubeadm deep dive session at KubeCon Europe 2020. That's on Wednesday, August 19. The presenters are going to be Ros Georgiev from VMware and Rafael Lopez from SUSE.
Okay, I'm going to highlight another one of our projects, the Cluster API. Cluster API is building a declarative Kubernetes-style API for creation and management of clusters. It also manages some of the infrastructure that is cluster scoped, things like networks or IAM policy from your cloud provider. It's focused around a declarative specification of the machines that become the nodes of the cluster. Some important things to understand. This is different from the Kubernetes cloud provider, which provides workload cloud resources like volumes and load balancers. This is provisioning similar infrastructure, but for the cluster itself. And one of the important design decisions was that the specification of a machine is immutable. But it's interesting in that Cluster API still provides the ability to upgrade the cluster. You may be asking yourself, how is this possible? How can the machine be immutable, yet the cluster can be upgraded and therefore be mutable? And the answer is that we follow a similar pattern as Kubernetes does. We don't just want to use Kubernetes CRDs, we want to follow the Kubernetes API design patterns. And in Kubernetes, there is indeed a similar design pattern. Pods are immutable, but pods are wrapped by replica sets, which runs a number of them. A replica set remains immutable, but a deployment creates mutability over those replica sets. It is able to create a new replica set and scales down the old one and scales up the new one. So we use exactly the same pattern in Cluster API. A machine, like a pod, is immutable. A machine has a number of replicas in a machine set, like a replica set, and a machine set is still immutable, but a machine deployment can create a new machine set, scale down the old machine set, and scale up the new one. A machine deployment is just like a deployment. And that's how we can achieve mutability at the machine deployment level. The machine is the same CRD, whether this is on AWS or GCP or VMware. And there's an analogy here to storage classes in Kubernetes. There is similarly a machine class. A machine class is a Kubernetes object that describes attributes of the machine that are specific to that cloud provider, just as a storage class describes attributes that are specific to a particular storage backend. Cluster API is a newer API, and we've actually developed our thinking around this design pattern over time. Machine class objects are actually typed objects. It has a different kind on AWS than on GCP. AWS is an AWS machine template. GCE is a GCE machine template. This allows for the fields of a machine class object to be specific to the cloud or infrastructure provider. And that allows us to get richer type checking and validation than we do in the storage class, where a storage class has the same kind across all the storage backends. So, not only reuse, but also evolution of the Kubernetes design patterns. So let's talk a little bit about the Cluster API roadmap. Cluster API is still in alpha, so how does it get to beta? Generally, the main goal is to get it into widespread real-world use and continue to get feedback on whether our expectations match how this thing is used in production. More automation also helps with this goal, both automation of testing and of the project processes. But the next couple of alphas are going to focus on some of those blockers, robustness of the control plane, a few features like auto-scaling and spot instances, some improvements to the primary user-facing tool called clusterctl, and in the alpha after that, resiliency of the nodes, extensibility of load balancing, using the latest features from some of the other SIG subprojects. In order to get to beta, the really big thing we need is better documentation, which goes hand in hand with more feedback from real-world users like you. Also, getting it integrated into some of those higher-level tools. So, for example, COPS is planning to support Cluster API initially for the nodes, and getting the existing Kubernetes E2E tests using Cluster API on GCP and on AWS. As you can tell, Cluster API is an exciting and rapidly evolving project. Nadir and Cecile are giving a deep dive talk on Wednesday, so if you'd like to learn more, I highly encourage you to attend that.
Another project that we wish to highlight is Component Config. Component Config is a Kubernetes-style API for configuring components. And Component Config is trying to solve some problems. The first one is that the core Kubernetes components are not consistent in how they are configured. They use a lot of flags, and oftentimes the flags across different components that do exactly the same thing have different names. The solution for that is that the core components should implement component config, and in fact most of the core components have already started doing that. Another problem is that it's pretty hard to write a case-like component with declarative config. So adding a component config itself is not that easy. So the solution for that is that we should factor common logic for component related code in the repository designated for that. That is component base. And it's a toolkit. It's going to make it easier to write a new component that immediately implements a component config that uses a Kate's API style of configuration, and existing components should be retrofitted to use the same toolkit. Component config gives us a lot of benefits. It has maintainability, so when a component has a flag set that grows over 50 flags, configuration becomes painful. Upgradability, so for upgrades, version configuration is arguably easier to manage than flags, since flags are unversioned. Programmability, configuration expressed as JSON in YAML objects allows for consistent manipulation, templating, patching, and introspection. And also possibility, many types of configs simply cannot be expressed as key value pairs. And finally, it's also declarative. OpenAPI information can be exposed using component config and used for generating documentation for your config. To learn more about component config, you can watch this talk that Lucas Kellstrom gave at the previous KubeCon. And in this talk, you can actually see some of the details, implementation details, around how we are actually implementing component config in existing components, or how do we want future components to implement it. In Kubernetes, we have a working group that is called Component Standards. It's a combined effort between SIG-Cluster Lifecycle and SIG API machinery, trying to tackle some of these problems around component config. To get engaged or find more about it, you can follow these links.
I wanted to talk a little bit about how you can get involved. Most of the projects we've described are not yet in GA. Kubeadm is, some of the high-level provisioning, cluster provisioning tools are, but otherwise the projects are in beta, in alpha, or even pre-alpha. So we need your help. And I'd suggest this is also an opportunity. Sometimes as a Kubernetes contributor, it can feel like everything that can be done has either already been done or there are 10 existing issues stating why you can't do it. That is very much not the case in SIG Cluster Lifecycle. There's a lot of work still to do. That work is very concrete, and we are very oriented around encouraging contributors. Specifically, we have some onboarding documentation, which is a great place to start, along with our community page. Many of the subprojects are excellent at triaging issues. They label issues with good first issue or help wanted to try to steer you to issues that don't require the in-depth knowledge that you'll likely gain over time. A great way to get involved is with documentation or even just trying out different things and reporting any issues you encounter. There are a number of Zoom meetings. There's an overall SIG Cluster Lifecycle meeting bi-weekly, and many of the subprojects have their own bi-weekly meetings as well. So please attend, ask questions, introduce yourself on Slack. There's a very active Slack channel where you can find people at all hours of the day and night. If you're not yet a Kubernetes contributor, I encourage you to attend the new contributor sessions that are run by SIG Contributor Experience. In general, the Kubernetes community philosophy is that you earn your place at the table by chopping wood and carrying water, by taking on the tasks that need to be done. So everyone is expected to get involved, and the flip side of that is that you are therefore welcome and encouraged to get involved. If you want more SIG Cluster Lifecycle content, there are 2 other talks of particular relevance to SIG Cluster Lifecycle. On Wednesday, there is a talk about Minikube, and on Thursday, talk around component config, dynamic configuration with component config and the control loop.
SIG Cluster Lifecycle is running a survey for 2020. In this survey, we have some generic questions like cluster sizes, different mechanics, usage of cloud providers, but also we have some questions specific to sub-projects like Kubeadm and Cluster API. So if you are interested, please find the time to fill this survey. It will be very appreciated. We have reached the end of the presentation. Thank you very much for your time, and now we can have a Q&A session.